Here we are dealing the very basic level models, parsing circuits. Also, we need to do some more models in the same, but okay, fine. Here you see a situation where the space between two concentric conducting spherical shells of radii capacitor. Leaks. They can't hold the charge for a long time. For a short time is okay. Long time, you will notice some discharge. Why? Because even though they were dielectrics filling the space between the plates, they are not ideal insulators. That's the problem. Leaky capacitor. Okay. So leaky capacitor, basic much manisha నేను వచ్చే లోపలికి ఏం కాదు పక్క క్లాస్ బాగు చేస్తున్నాను అంతే నేను పాడైపోయిన పెద్ద పట్టించుకో leaky capacitor. So identification of leaky capacitor is space between electrodes filled with a dielectric with considerable conductivity. Ideally, it should be zero. Capacity of a capacitor that's some space with considerable rate. Can you please remind me about resistance of a thick spherical thick sphere? Inner radius A, outer radius B. Resistance is rho by 4 pi times B minus A by AB. That's the formula, if I'm not mistaken. Right. Correct, na? Sure? Tell me correct or not here. Right. In this case, it is rho by 4 pi times 2A square rho by 8 pi A resistance. What is the expression for capacitance? 4 pi epsilon naught 1 by A minus 1 by B, AB by B minus A. B is 2A. So finally, this is 8 pi epsilon naught epsilon R. Yes, sir. Epsilon naught epsilon R A. Okay, na? What is the equivalent time constant of this arrangement? RC. RC is rho by 8 pi A 8 pi epsilon naught epsilon R A. Want to have to strike this. This is epsilon naught epsilon R rho. What is RC? Time constant. Now, how to identify this arrangement? This arrangement is to be identified as if that you have some plus Q minus Q charge and you are connecting it by means of some resistor R. Can you please help me in writing the arrangement at any instant charge? Q times e to the power of minus t by tau. So Q times e to the power of minus t by epsilon r rho. So what is correct? ఇక్కడ మైనస్ సరిగ్గా కనిపించట్లా. Right. Done everything. What else you are looking at me? ఇక్కడ రెసిస్టెన్స్ 8 రో బై 8 పై ఏ ఉండాలి. I have done everything. Leaky capacitor, one model is what I have. See, when I am dealing, I am covering regular basic models from Singage, some problems from Irido, Pathfinder maximum, SRG, which is a very difficult book. All the questions I am covering. Class tests, you are practicing, and I am giving a difficult set of questions also for practice. Remember, when you are in second year, when you are in revision program, you don't need to search for fresh content. This is the one which you will prepare again. So if we are learning now with some compromise, that three things are possible. One, what is that you are teaching is not my zone. I will adhere myself to basics. You will face problems in the revision. Two, you act now as if that you understood everything, but you are not convinced with certain areas of the flow. You will face again the same problem in revision. You will bring the book or teach me this. This is the reason why now I am recording every class. Last but not the least, you are cheating your own personality. I'm giving you opportunity. Now, you have any doubt, you can ask. Because there is a scope that you might have some doubts in the process of learning here. This is the first time you might be going through a lot of things. You can ask. Sir? Now, this already we have done yesterday. I'll come to this later, before which we will work on the same area, leaky capacitor again. 3.160. Start. The Irido question. The gap between the plates of a parallel plate capacitor is filled with the glass of resistivity. Giga 10 power 6, well, peta 10 power 15 giga. So therefore, resistivity is 100 into 10 power 9 ohm meter. Practical grounds, it is a insulator. The capacitance of the capacitor is equal to 4 nanofarad. leakage current. What to do here? It's first of all resistance. Resistance. If you ask, fortunately, these are parallel plate capacitors. So therefore, resistance is rho into distance between the plates by cross-sectional area. Equation 1. Okay. So this you not given, but okay, I'll deal this later. My issues. Capacity is epsilon. Actually, the problem is they did not mention anything. Glass will have certain dielectric which you need to search later on. That I assume some K is dielectric constant. Because in Irido, the first page itself, they will give constants. They don't give every time this part. C is equal to epsilon K epsilon naught A by D. So the time constant is RC, which is nothing but K epsilon not rho. I don't see that I am teaching any news. Equal to I is equal to I naught e to the power of minus t by tau. I is equal to I naught means V by R e to the power of minus t by k epsilon naught rho. Enjoy circuit. Just want to stop over here. V by R. కెపాసిటెన్స్ ఇచ్చారుగా C is we know K from the data of Iridu. Okay, I am not see. I just want to say this is the model, right? Next, my interest is just to close till here. That's all. Super. Two conductors of arbitrary shape are embedded into a infinite homogeneous poorly conducting medium with the resistivity rho and permittivity epsilon. Okay, find the product of RG. What is this? Resistance of the medium between the conductor and C is the mutual capacitance of the wires in the presence of the medium. This is 3.161. The mutual capacitance of the wire in the presence of the medium. Two conductors of arbitrary shape. Arbitrary shape. I am assuming this is the minus conductor. You said arbitrary shape. This is the plus conductor. Yes, this is a capacitor. I told you. Right. Because you said arbitrary shape. It's in infinite homogeneous, poorly conducting medium with resistivity rho and permittivity so and so. You want resistance in between this part, right? What we will see is that generally on a normally electric field lines. Actually, this is how it is. So I'm drawing conditions, long time back story. Now you consider very close equipotential surfaces. They're very close equipotential surfaces, and let dl be the very small distance between. Very close is what I told. Very close. So consider what are they? Two nearly equipotential surfaces in this region whose thickness or distance of separation be delta L. And for my confirmation, I have drawn very big. Actually, they are very, very small. Let delta S be the area of the equipotentials. Why I require all this stuff? If resistivity dl by ds or delta S, okay, makes no difference. Okay. So close to parallel plate condition, we will have C is epsilon naught A by D. You know this. You are allowed to use this for parallel plate. Therefore, I cannot write it like this. I can maximum say as if that and there is a dielectric constant also, no? So take both. dl by ds can be written as this is a constant totally of the medium. Now you take integration on both the sides. So finally what you will get is R is some epsilon naught k rho by C. Now you need to understand for such mediums RC very vast distributions. You can blindly use epsilon naught k. 3 times we got the same. That's the RC value. So which means the time constant is epsilon naught k rho. What do you want? Let's solve. Done. And 3 times I have done the same question, I got the same relation. Ah, I'm assuming these arbitrary conditions. If you are interested, you can do in your own style and bring the same result. I welcome it. Next, 3.166. The gap between the plates of a parallel plate capacitor is filled up with two dielectric layers. L1, already we have done this question in Pathfinder, one comprehension passage. Dielectric layers 1 and 2 with the thickness D1 and D2, permittivity is epsilon 1, epsilon 2, resistivity is rho 1 and rho 2. A DC voltage V is applied to the capacitor. It's a comprehension passage in question different. Okay. Two different dielectrics. Epsilon 1, rho 1, D1. T2, epsilon 2, rho 2. The epsilon term itself contains the dielectric property. If sigma, the surface density of extraneous charges at the boundary between the dielectric layers and the condition under which sigma is equal to 0. A question on miss ayipinda, right? What is the effective resistance of the system? First of all, you have applied this one also, DC voltage V. Effective resistance is rho 1 T1 by A plus rho 2 D2 by A. I don't think you have given conductivities. They have given resistivities only. Right. Good question. What is current? Current I is equal to potential difference by resistance. So V by rho 1 D1 by A plus rho 2 D2 by A. Any doubt till this point? Any doubt till this point? Boys and girls, any doubt till this point? This your option. Answer. Next. It is simply rho 2 T. Okay. What do you want? Extraneous charge. You know, current density is E1 by rho 1 or E2 by rho 2. From Ohm's law. Ohm's law in vector form, right? Correct. What you want actually? You want E1. Okay, fine. E1 is rho 1 V by rho 1 D1 plus rho 2 D2. What is E2? Rho 2 V by rho 1 D1 plus rho 2 D2. Done. And you know how to apply Gauss law in dielectrics. So in Gauss law in dielectrics, K E bar dot ds bar is 1 by epsilon naught Q free. But they are asking extraneous charges means free charges, not bound charges. They are asking extraneous charge means bound free charge. For this purpose, epsilon 1 E1 minus epsilon. I think I should do minus plus minus epsilon. ఏమైంది ఏమైందా అంటే ఎప్సిలాన్ ఇంటూ కేనే కదా ఎప్సిలాన్ కరెక్టే కదా ఎందుకు పాజిటివ్ టర్మినల్ లెఫ్ట్ సైడ్ కరెక్ట్ 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 చెప్పు అప్పుడు ఏమవుతుంది ప్లస్ ఎందుకు వస్తుంది ప్లస్ సిగ్మా కండక్టివిటీ కాదు ఇంకా ఇది జనరల్ గాజుల ఎటుంది వచ్చింది ఇంకా ఇట్ మే టేక్ టైం వన్స్ ఇడియట్ పీపుల్ స్టార్ట్ ఓపెనింగ్ ట్యాబ్స్ ఆటోమేటికలీ దిస్ విల్ లూస్ నన్ను యు ఆర్ ఆస్కింగ్ సంథింగ్ For example, I am assuming sigma is for example, sigma is positive. Suppose if I am wrong, that is get corrected accordingly. You haven't given me anything about whether it is sigma 1 greater than sigma 2 or sigma 2 greater than sigma 1. No such information. So I'll take like this. Suppose if I am wrong, it will taken care in the magnitude of. No issues. What is the difference? ఎందుకు నెట్ ఎలక్ట్రిక్ ఫీల్డ్ మనం తీసుకుంటుంది. ఎనీ డౌట్స్ అందులో క్వశ్చన్ లో దాట్ అండ్ దీస్ ఆర్ డిఫరెంట్ థింగ్స్ రైట్. 3.168, very fast. With this, I will close Irido. Model. ఇంకొకసారి అడుగు మళ్ళీ నాకు ప్రాపర్ గా. Because I don't know the capacity of the arrangement. Small portion I know, not full volume. That's the problem. Portion capacitance we have considered. Yeah, please work on this immediately. కరెక్ట్. తప్పదు అన్న. ఫీల్డ్ సెట్టింగ్స్ అంటారు. మీరు రేపు సెకండ్ ఇయర్ లో ఉండండి. ఇది ద స్పేస్ బిట్వీన్ ద ప్లేట్స్ వెరీ ఫేమస్, వెరీ ఫేమస్. రైట్. అరే ఒక చిన్న హెల్ప్ ఏంటంటే, ఇంకోటి ఎవడన్నా ట్యాబ్లో పెట్టి డిలే మీకు కూడా ఇంతే వస్తుందా అనేది చూడండి. ఎందుకంటే ఇఫ్ ద డీలింగ్ విల్ ఆల్సో గో రాంగ్. ఉంటున్నాయి. రైట్. ఈ క్వశ్చన్ ఈ కేసులో మీరు లీకీ కెపాసిటర్ కాన్సెప్ట్ వాడినక్కల, బికాస్ ఇట్ ఈస్ ఎ కాన్స్టెంట్ బ్యాటరీ. లీకీ కెపాసిటర్ ఎప్పుడు వస్తుంది? యూ చార్జ్ ద ప్లేట్ అండ్ దెన్ ద ప్లేట్, ద రీజియన్ బిట్వీన్ ద ప్లేట్స్ ఈస్ ద మీడియం ఫర్ డిశ్చార్జ్. If it happens spontaneously, then we won't study as a leaky capacitor, because dielectric, poor resistance, poor conductance. It happens very slowly, as if like, imagine a very minute a porous type hole is there in a pot. You filled the pot fully, kept at night, assuming that by morning it will become chilled and I will drink that chilled water. The problem is the leakage is there slowly, and by the time you open the pot, almost 3/4 is empty. That is called a leaky capacity. Very simple. The space between the plates of a parallel plate capacitor is filled up with the inhomogeneous, poorly conducting medium, whose resistivity varies. Resistivity, not resistance. Resistivity varies linearly in the direction perpendicular to the plates. So for this purpose, I am assuming you said it is a linearly varying. Linearly varying means, okay, one more important point is the maximum by minimum value is given as eta. So suppose if it is a rho 1, the end portion is a rho 2, you will write this as rho is equal to rho 1 plus rho 2 minus rho 1 by L times X. ఇక్కడ ఏం రాస్తాం? rho naught plus eta minus 1 by eta minus 1 by distance between the plates D times rho naught X. Simply you can write this as resistivity. First part I have decoded. Find the volume density of the charge in the gap if a voltage V is applied to the capacitor. Epsilon is assumed to be 1 everywhere, and dielectric constant is equal to 1 in our normal terms. I still doubt why this question is here. But okay, maybe I would have missed that earlier, because Pathfinder questions and Irido questions we are completing now only. We are making our notes good voluminous and precious, right? Now, how to find resistance of this system? Integral rho dx by a, which is rho naught by a times 1 plus eta minus 1 by d times x dx 0 to d. Now, finally, what is going to be the fate of this? Rho naught by a times by a d plus eta minus 1 by 2 d. I think we can decode this further as rho naught by 2a times eta plus 1 time. I doubt 1 minute. A 2d plus eta d minus d. So finally, I'll take d out the common. So rho naught t by 2a times I got the resistance. Fine. Now you know resistance, you know voltage, so you know the current, and you know the current density also. You know the current density also. So what is current density here? Current density is current by cross-sectional area. Voltage by resistance into area. Resistance into area can further be written as 2V by rho naught d times eta plus 1. Obviously, it's a constant because it's a series situation. But they are not asking you about this. See, just try to recall Gauss law is in two forms. One which you know E bar dot ds bar is 1 by epsilon naught times the charge enclosed. There is another form, del bar dot E bar is rho by epsilon naught, and that rho is free charge undoubted. Find the volume charge density of the charge in the gap if a voltage where the gap width is equal to t. So what exactly you are expecting there? Pardon? So fortunately, this is not a spherical or cylindrical system. It's a plain X-based system. So this you can write dou E by dou X is rho by epsilon. J times rho. We know E is equal to rho J. E is by a rho. Rho is rho naught plus 1 plus eta minus 1 by d times x j. చివరిలో మార్చుకుందా j. J is anyway constant. Rho naught j. So, అరే మళ్ళీ మీకు దండం పెడతారు రో ఆ రో ఈ రో వేరు వేరు రో చార్జ్. Otherwise, you may suggest me to cancel this and that simultaneously. Dou E by अरे यार इसमें रो नॉट j कांस्टेंट and eta minus 1 by d will be left here. Rho charge by epsilon naught. Hold on. Rho naught times 2v by rho naught d eta plus 1 times eta minus 1 by d is rho charge by epsilon naught, which implies tell me, rho naught cancel 2 epsilon naught V by D square eta minus 1 by eta plus 1. 2 epsilon naught V by D square eta minus 1 by eta plus 1 is rho charge. Boys and girls, any doubt? This is also a very famous model. With this, I think to some extent, what sufficient stuff is required that I have done. Okay, if it is required, then right, I will deal some more, but please let me go for the other part. Okay, I'm just switching from here to the next part. Right. This is the question which I wish to discuss. '94. Remember, this is one important model which now I need to rush because my target is to close a lot of questions today. There is another thing I know that post office box is there that I will discuss Friday. No issues. You have two neutral spherical conductors of radii 2a and a respectively by a large distance. Initially, switch S1 is closed, kept closed, and S2 is open. Obviously, you are charging the first capacitor. I'll call this as C1. I will call this as C2. C2 is 4 pi epsilon naught A. C1 is 8 pi epsilon naught A. Any doubts? Initially, you charged one capacitor. You charge one capacitor just because you are closing S1. So closing S1 with S2 open results charging C1 to C1. Thereafter, you are opening S1. Thereafter, you are opening S1 and closing S2. From here, I don't see the question like this. From here, I will see as if the question is given like this. This is discharging. Right? ఎవరన్నా ఇది ఓపెన్ చేస్తూ అక్కడ సేమ్ వస్తుంది. You didn't answer me properly. Okay. But ఇందులో ఎలా వస్తుందో మరి. Okay, right? Right. That's the situation. Now, I'm assuming at an instant Q charge is flowing. Here it is Q minus q. Any doubt till this point? Play rule. R plus zero. So which clearly indicates dq by dt times r is uh, minus of minus plus. Okay. Total minus kada. Just keep this terminology only for some time. This is a dq by that's the d. Because initially there is no charge. This can be written as because you can write C1 C2 by C1 plus C2 as C effect. Nana Chapra. That's Q. Okay, what do you want? Find the rate of fall. That no one is taking care of this part. They're asking find the rate of fall in potential of the conductor of radius 2a. Then no one is asking all this stuff at a given instant. At a given instant. At a given instant. Charge on 2a is Q minus Q. So this is nothing but correct అయిన calculation ఒకసారి చూడండి. Yaar, please confirm the calculation once. I doubt something is wrong. Put P is equal to 0, what happens? Q. Put T is equal to 0, man. You'll get a Q, capital Q. That's true. But T tends to infinite. QC1 by C, and we know sharing of the charges, that's true. Done. But who cares? This is not my. Now let this be some Q dash. So potential drop across capacitor. Q dash by C1. You want T by dt of well. చూడండి రా, ఇంట్లో సిచ్యువేషన్ అట్లా ఉన్నా వచ్చాడు రా, అది ఎంత నిజాయితీగా ఉంటున్నాడు రాడు. ఇప్పుడు మార్కులు రాకపోతే వాలంటరీగా వైట్ ఉంటున్నారు. మనలో ఎంతమంది ఏడ్చారా అంత నిజాయితీగా? ఈడే లేడు. ఎందుకు పోయిందిరా అంటే ధైర్యంగా నేను చదవాలా, నాకు పోయింది. అదొకటి కొంతవరకు. నాకు ఈ వీక్ ఫిజిక్స్ చేయాలని అనిపించటల్లా, అందుకు పోయింది. ఇంకో రకంగా రై, నీ మొఖం నాకు నచ్చలేదు ఇవాళ, అందుకే నేను రేపు పరీక్ష అడగొడేస్తా, అది ఇంకో రకం. మ్యాథ్స్ లెండీగా వచ్చింది, కెమిస్ట్రీగా ఈజీగా వచ్చింది, బయట డప్పులు కొడుతున్నారు, వెనక ఎండ వేడిగా ఉంది, ఏసీ నాన్నెత్తి మీదే పడింది, అందుకు ఫిజిక్స్ సార్ ఏం రీజన్ లేదు. రైట్. ఇప్పుడు దీన్ని డిఫరెన్షియేట్ చేస్తే ఫస్ట్ టర్మ్ 0, అంతేగా? ఫస్ట్ టర్మ్ 0, నెక్స్ట్ టర్మ్ R into C effective. C effective అంటే C1 C2 by C1 plus C2. Proud to cancel both. E to the power of minus T by R C effective. So finally this is dV1 by dt. Okay. Don't put the final answer as a negative term because they are asking that will be గుడ్. నా మంచి పని చేస్తావు, కాలేజీకి వచ్చావు అవసరం ఉన్న రోజు కూడా. గుడ్. ఎక్కడ C1 స్క్వేర్ వేసా, ఎడ క్యూ ఉంది? క్యూ ఒక నిమిషం ఉంది, క్యూ ఉంది. ఓకేనా? దట్స్ ద డీల్. అసలు నేను చేసింది కరెక్టే కాదు, అప్పుడు ఎప్పుడో చేశా. అసలు ఫస్ట్ ఆఫ్ ఆల్ ఇప్పటిదాకా మనం ఆ సబ్స్టిట్యూషన్స్ ఏం చేయలేదు వాస్తవానికి. అసలు ఫస్ట్ క్యూ అంటే ఏంటి అదిలారా? నాకు తెలుసు. క్యూని ఏమని పిలుస్తారు? C1V. ఇప్పుడు దీనిలోకి సబ్స్టిట్యూట్ చేయాలిగా. క్యూ అంటే C1V, పైన C1 కింద C1, డన్. V by R C1, T to the power of minus T by R C effective. C effective అసలు ఏమవుతుంది? 8 epsilon naught A into 4 epsilon naught A by 12 epsilon naught A. కరెక్టేనా? దాన్ని ఏమని పిలుస్తున్నారు ఇప్పుడు? 8/3 pi epsilon naught A. రెసిస్టెన్స్ ఆర్ ఇచ్చాడు ఏమన్నా వాల్యూ? నో. ఆరే. సో ఆన్సర్ ఏం కావాలి ఇక్కడ? ఇంకా V by 8 pi epsilon naught A or e to the power of minus 3t by 8 pi epsilon naught A or this is minus dv1 by dt. Any doubts? Any doubts in this? ఆడైతే వెంటనే చదివేదో చదువుకుంటాడు. వెంటల్ మొత్తం ఆపేసి నువ్వు కాదురా వీడు ఆపేసి చేయమంటే నువ్వు చేయలేవు, నాకు తెలుసా కదా. మరి ఎందుకు నీకేమని చెప్పాను రా? అటు వెళ్తే ఇటు అనరా? నేను నా పాఠంలోకి నేను వస్తాను, అసలు మాట వింటలేదురా. రషీద్ గారికి చెప్దామంటే వాడే నిద్రపోతూ ఉంటాడు. కొంచెం యాక్టివ్గా ఉంటావు కదా అని నీకు చెప్పా. రైట్, నెక్స్ట్. అయిపోయిందిగా? క్వశ్చన్ అయిపోయిందా? నో. హీట్ అడిగాడు, అడిదేం పోయింది అడుగుతాడు హీట్. సరే, ఇప్పుడు క్వశ్చన్ అవుతుందిరా, గుర్తుందా మీకు? పాతది. వెన్ ఐ టాట్ యూ కెపాసిటర్ some 3-4 years back, ఈ పాయింట్ ఆఫ్ వ్యూలో అంతేగా. అన్చార్జ్ లాస్ ఎక్స్ప్రెషన్ చెప్పండి. ఆఫ్ C1 C2 by C1 plus C2 V square. ఇప్పుడు అంతే. Therefore this is a half 8/3 pi epsilon naught A V square. So that will become 4 pi epsilon naught A V square by ఏదో అడిగాడు ఒకసారి, అది చెప్పరా ఒకసారి మళ్ళీ క్వశ్చన్ క్లారిటీ గాడు. ఇప్పుడు ఈ లాస్ అయిన హీట్ మాత్రం ఎక్కడ లాస్ అయిందని నీ ఉద్దేశం? చెప్పరా, ఈ లాస్ అయిన హీట్ మొత్తం ఎక్కడ లాస్ అవుతుంది? అసలు అంటూ లాస్ అయితే ఇక్కడ లాస్ ఎక్కడ జరుగుతుంది? హీట్ డెలివర్డ్ ఎక్కడ జరుగుతుంది? కెపాసిటర్ లో లాస్ ఏ ఉండదురా ఎప్పుడు, రెసిస్టెన్సే. ఎంటైర్ లాస్ హ్యాపెన్స్ ఎట్ రెసిస్టెన్స్. ఏ కేసులో? ఏ రెసిస్టెన్స్ లేని కేసులా? ఆ కేసులో కూడా ఎంతో కొంత ఫైనైట్ రెసిస్టెన్స్ లేకుండా ఉండదు. దట్ వైర్ బికమ్స్, కండక్టింగ్ వైర్ బికమ్స్ వెరీ హాట్. లాస్ హ్యాపెన్ వెన్ ఎవర్ దెర్ ఈజ్ ఫ్లో ఆఫ్ చార్జ్. కరెక్ట్. ఎక్కడ పోతుంది? ఇన్ వాట్ ఫార్మ్ ఇట్ విల్ బి లాస్? నాట్ సౌండ్, నాట్ లైట్. ఓన్లీ వన్ పాసిబిలిటీ is, then you may ask me that time why you didn't told. Resistance is very small. So what happens is, in no time that much amount of heat is delivered in that conduction. Now what happens? Same loss will happen for a long duration. Same loss, duration is high, that's all. If you don't believe me, I have no problem. At any time, what is the potential drop across the two, you know now clearly, right? Now on that basis we apply I square R. On that basis you go with integral I square R dt. Finally you will come to my same direction. Okay, any doubts? Clear? You explained last week, mentioned that conducting when no resistance is present, like this case. No resistance is impossible. particular no resistance. But no resistance means impossible. Any conducting path will have minimum resistance. Conducting wire EMF. 1 ohm, even if it exists, that's fine. When you don't separately resist. No, there such a situation is not possible. Even wire will have resistance. Loss happens only through that conducting wires itself, but very high in no time. In no time, so very high. Even they might melt also. They might melt also. Okay. Now you see capacitor charge fan condenser will be there. You charge the condenser just placing one wire in neutral and the other one in the live wire, and thereafter you touch both, you'll see spark. That much fast. Okay. Right. Any doubt still? Condenser is nothing but capacitor. Size big. Used in electrical instruments, condenser. Very small capacitor. Go ahead. You should get 1 to 1.87 microjoules. Go ahead. Is it okay? One, two. One, 3, 4, 5, 8, 13, 14, 15, 16, 17, 18, 19%. So what is happening over here? A charged capacitor C1 is equal to 3 microfarad is getting discharged in the circuit shown. When the current I was observed to be 2.5 amps with S was opened. Okay. Determine the amount of heat that will be liberated in the circuit after S is opened. I didn't get you. What is your initial situation? A charged capacitor, 3 microfarad, is getting discharged in the circuit shown. When the current is, no, 1 minute. I have 3 stages involved in this question. The first stage, This is the first stage. Now I know the relation here as I is equal to I naught T by tau. So in this particular with when the current I was discharging in the circuit, when the current I was observed to be 2.5 amps, switch S was opened. Till this point, the right side capacitor is not in picture. Till S is closed. Okay. C2 have no role. Why? It's short circuit. So now you said the C1 is equal to 3 microfarads getting discharged in the circuit. Now, very clear, I can say that at that instant, the potential drop across the circuit is 2.5 into 4 10 volts, which means at C1, potential drop is 10 volts. Charge is CV, 30 microcoulomb. Now, this is T is equal to 0. That is the instant where I'm entering into the problem. And now I just want a confirmation from every student of this class whether you understood my starting point. In the question, he said that he is charged. is charged, but he did not say that one is charged. See, I'm assuming one has no choice of even having a charge. Short circuit. The moment when S is closed, instantaneously it will be discharged. Discharge. In fact, to reach 2.5, it may be some I naught initially. So I naught to 2.5, it will take some time. Whereas in case of C2, it has nothing to hold some time. Zero, instantaneous. Means in that 2.8 discharge. Yes. So by that time you are observing, it's already discharged, neutral. And now my charge across C1 is 30 microcoulomb. And this is the starting step of the question. I'm just questioning everyone in this class. Are we clear? You said it will automatically get discharged fast in no time. C2. C2. It will get discharged. So, and we know that discharge will be we can, instead of discharge, we can go directly wire. Yes. Wire. Yes. So, sir, that's the reason I did not show anything right hand side. This is also same, so directly wire. Yes. And when discharge, that will also be like the same. Let it be here. See, the moment you started the discharge, left hand side, the next instant, within no time, C2 becomes 0. But still C1 have some charge. C1 will have C2 can discharge 0. So you can put a wire instead of the capacitor. Ore in petting the diagram. Is this okay now? Draw a blue line. నేను అసలు బొమ్మే చూపించలేదు కదరా మీకు. ఐఎమ్ జస్ట్ టెల్లింగ్ దిస్ వాడు చెప్పరా బాబులు. What is the picture? At t is equal to 0 plus q minus q r now C1 is in picture, C2 is in picture because you lifted this portion. 0, 0. C2 is 0. Any doubts? Now, this is t is equal to 0. Just now we have done The drop at this point V1 is equal to 10 volt. V2 is equal to 0. C1 is equal to 3 microfarad. C2 is equal to 1 microfarad. Just now I told you loss is across R. వాడు ఏది ఇచ్చినా నా ఆన్సర్ ఇదే. హాఫ్ ఇంటూ 3 into 1 into 10 power minus 6 by 4 V square 100. Okay, na? So they are not asking anything related to the instantaneous charge, nothing. So I got answer as 37.5 microjoules. I got the answer as okay na ipudu 30 done. Any doubts? But if they ask any at an instant what is the charge, I am not going to teach this again. Why? Because same old model. How the way I have done this question, you are allowed to do in the same. Got the point? Right. Next. Now I'll jump into the world of Pathfinder because I have done sufficient time with the basic. I think I have done this question right. 15. Done this question. 15. Confirm. There is no capacitor related questions here. Proud to say that majority of the questions were done. Air-filled parallel plate capacitor with plate area A is connected to a battery of electromotive force V, negligible internal resistance. One of the plate is made to vibrate so that the distance between the plates varies. And this is some point of interest that someone need to focus. Instantaneous current in the circuit reaches a maximum value of I0. Maximum possible amplitude of vibration. Actually, what is happening? For our understanding, I am writing a bigger. It is vibrating about that y-axis line. Vibration is happening about this line. So your vibrations are confined తీసుకోండి చూసుకోండి మీరే. So what is this point? A అలా ఎలా జరుగుతుంది? నీకు అనవసరం, అన్ని నీకు చెప్పు చేయాలంటే. Yes. What is actually happening? This is V. At any time, charge is CV. Epsilon naught A by T naught plus A cos omega T V. Any doubts? అంటే మీ ఇష్టమా బైనామీలు తిరిగి నీకు అనుగుణంగా ఇప్పుడు పడితే అప్పుడు ఎలా పడితే అలా వాడేస్తావా అని నా వంక చూశారు. నేను ముందరే చెప్పి ఇది ఎందుకు ఇచ్చాడో చూసుకోండి, అంతే కదా. జస్ట్ సపోర్ట్ బైనామియల్ ఎక్స్పాండ్. రైట్. శ్రేయస్ గా క్లియర్ గా ఇక్కడ దాకా బహుశా పిక్చర్ అర్థమైపోతుంది. If the instantaneous current reaches a maximum value, n ఎందుకబ్బా ఫస్ట్ dq by dt epsilon naught a v by t naught square a omega sin omega t. దీన్నేగా కరెంట్ అని పిలిచేది. ఎప్సిలాన్ నాట్ ఏ వి ఒమేగా ఏ బై డి నాట్ స్క్వేర్ సైన్ ఒమేగా టీ. మీకు నేను చెప్పేది ఏముందో చెప్పండి. ఈ పార్ట్ ఐ నాట్ ఈస్ వాట్ యు వాంట్? maximum possible amplitude of vibration is given epsilon naught a v omega a by d naught square is I naught. So you want a is I naught d naught square by epsilon naught a v omega. అసలు ఉంది ఆప్షన్, ఇంత అడౌట్ చేస్తున్నా. I naught d naught square by epsilon naught a v omega. Right. 14th question. Because I am recording this. C. Absolutely correct. Correct. చెప్పాల్సినప్పుడు చెప్పు. ఇప్పుడు చూస్తున్న ఎక్స్ప్రెషన్. It's absolutely correct. Sorry, I'll go to 15 later. I think I've done last week, if I'm not mistaken. Otherwise, also no issues. Our basic criteria today is RC circuit. Previous class అయిపోతూ ఉండగానే జస్ట్ యూ ఆస్క్ పెట్టేమది. వంశీ సార్ కూడా కావాలి. But I think I need to do some stitching work between this year's and last year's one. తేడా ఉందా క్వశ్చన్ పేపర్ లేవాలి
లేదు. 10 నిమిషాలు మిమ్మల్ని చూస్తే కూల్ అవుతారు.
ఎవరు
సింధు పేరెంట్ 2 minutes.
5 minutes ఇస్తే క్వశ్చన్ ఫినిష్ చేస్తా ఓకే కీప్ వర్కింగ్ ఆన్ దిస్